Hi, this is Swati, and in today's video, we'll see quadrilaterals of class ninth. So, we have learnt about quadrilaterals. It has four sides, four angles, and four vertices. So, quadrilateral is any four-sided figure, whatever shape I make of a four-sided, like let's say this. This is a quadrilateral because it has four sides. So, this is one side, this is another side, third side, fourth side, and it has four angles: first angle, second angle, third angle, fourth angle, and it has four vertices: first vertex, second vertex, third vertex, and fourth vertex. Any four-sided closed figure is a quadrilateral. So we have so many types of four-sided figure. Here we see rectangle, square, rhombus, parallelogram, kite, trapezium. All these are quadrilaterals because they are four-sided figures. So what is a rectangle? We already know that in a rectangle, opposite sides are equal and all angles are 90 degrees. And in a square, we know that all the sides are equal and all angles are equal to 90 degrees. Rhombus, again, all the sides are equal, but the angles are not 90. It is just all the sides are equal and angles are not equal. Parallelogram, the name itself suggests parallel. So the opposite sides are parallel to each other. Opposite sides are parallel, opposite sides are equal, opposite angles are equal. So everything opposites are equal. Now next is a kite. So kite, if we see, the adjacent sides are equal. Here AB and BC are equal. Similarly AD and DC are equal. The adjacent sides are equal. And next, a trapezium. Trapezium, as we know, opposite sides are parallel. Just one pair in a trapezium are parallel, not both. Just one pair is parallel to each other. So these are some quadrilaterals, four-sided figure. I think I've covered all. So in this chapter, we'll see some more theorems on each, and let's get started. So first is a parallelogram. So let us see these theorems. So in this video, I'm only explaining the theorems. So in case if you need the proof of the theorem, if your school is teaching the proof, I will definitely share the proof as well. Please comment if required. So now first theorem, a diagonal of a parallelogram divides it into two congruent triangles. What is a diagonal? Diagonal is a line joining the opposite vertex. So A and C is a opposite vertices. So when I join them, a diagonal is formed. So in a parallelogram, you have two diagonals, AC and BD. In any quadrilateral, you have two diagonals. So when a diagonal is drawn, it divides into two congruent triangles. So ABC is congruent to ADC. Next, in a parallelogram, opposite sides are equal. We have already seen DC is equal to AB and AD is equal to BC. 8.3 theorem. In each pair of if each pair of opposite sides of a quadrilateral are equal, then it's a parallelogram. See, any quadrilateral you take, quadrilateral is a four-sided figure. So if you prove that each pair is parallel to each other, then that quadrilateral becomes a parallelogram. So suppose I take this quadrilateral. So if I prove this is a quadrilateral, not square, not rectangle, not parallelogram, nothing. It's a four-sided normal quadrilateral. So in this, if I prove that one pair, both the pairs are parallel to each other, both the sides are parallel to each other, then this automatically becomes a parallelogram. Now next, in a parallelogram, opposite angles are equal. We have already seen angle B equal to angle D and angle C is equal to angle A. If in a quadrilateral, each pair of opposite angles is equal, then it's a parallelogram. Again, if we take any quadrilateral and if we prove that opposite angles are equal in it, then that quadrilateral becomes a parallelogram. Okay, next one here is the diagonals of a parallelogram bisect each other. So now let us draw the diagonal. BD is one diagonal, AC is another diagonal. Bisect each other means Here they are intersecting at O. Diagonals bisect each other means the diagonals are divided into two equal parts. So AO is equal to OC and DO is equal to BO. So AO is equal to OC, BO is equal to DO. So in the quadrilateral, in a parallelogram, diagonals bisect each other. Now, the vice versa, if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Again, if in a quadrilateral you prove that the diagonals are bisecting each other, it automatically becomes a parallelogram. So this was the all the properties of parallelogram. In short, I can write that opposite sides and opposite angles are equal in a parallelogram, right? And diagonals bisect each other. So this was all about the parallelogram, right? Now next moving to the diagonals. What are diagonals? Diagonals, as we know, that when a line is joining the two opposite vertices. So now let us see the diagonal properties of these quadrilaterals. First one, square. In the square, all the diagonals are equal. So here I can write AC and BD are equal to each other. Diagonals bisect each other. Bisect means the diagonals are divided into two equal parts. This equal to this equal to this. That means AO equal to OC and BO equal to OD. And last, diagonals bisect at 90 degrees. So here they are all 90 degrees at the center. Now next, rectangle of all the diagonals are again equal to each other. AC is equal to BD and bisect each other. The diagonals bisect each other. So AO equal to OC and DO equal to BO. All right. Now next is a rhombus. In rhombus, diagonals are not equal. Okay, here the diagonals are not equal, you can see. But diagonals bisect each other at 90 degrees. So here at the center you have 90 degrees. And diagonals also bisect each other, which means AO equal to OC and OD is equal to BO. Now this was all about diagonals. Now next up, we have very important theorem, midpoint theorem. So this is most important in this chapter, the properties and this theorem. That's it. You have only these two in this theorem. The properties that we had seen, you will have questions based on properties, and you have midpoint theorem. So what is midpoint theorem? So some also have proof of it. So if in case you need the proof of the midpoint, I'll be happy to explain that as well. Next, the line segment joining the midpoints of two sides of the triangle. It is already given the midpoints of two sides. So D is one midpoint, which means this equal to this, and E is one midpoint, which means AE equal to EC. Midpoint means it is dividing the side into two equal parts. So the line segment joining the midpoints of two sides of the triangle is parallel to the third side. So this is one side, this is one side. So which is your third side? Your third side is BC. So then DE will be parallel to BC is what is given. So here it will be given that the two are the midpoints. AD is equal to DB and AE is equal to EC, it is given. Then that midpoint line, the DE line, will be parallel to BC. This is midpoint theorem. I hope this is clear. Suppose I take the figure like this, ABC, ABC, DE. So now this is midpoint, this is midpoint, this is one side, this is one side. Then the midpoint line, that is DE line, will be parallel to AB, sorry. I hope this is clear. Very important. Now next, converse of it. So the line segment drawn through midpoint of one side. So let's say D is a midpoint. This is the first side. A line segment is drawn from the midpoint of one side. is parallel to the second side. It is given that this DE line is parallel to the second side. Second side will definitely be BC because DE cannot be parallel to AC. Okay, so if it satisfies these two, then the third line will be bisected. Therefore, AE will be equal to EC. This is the converse, that you have on one side you have a midpoint. The midpoint line is parallel to the second side. Therefore, it will bisect the third side. Now, for example, I have my, you know, like this. I have my figure like this. Let's see, like this. Okay. So this is P Q R S T. So see a line drawn through a midpoint of one side. So this is the midpoint. It is given. The line is drawn through midpoint of one side and is parallel to the second side. So using converse midpoint, I can tell that PT will be equal to TR. The third side will be bisected. I hope this is clear. So just in case if you need the proof of any of the theorem or all the theorems, you can just comment me and I will get back with it. So this chapter is all about the properties of the quadrilateral and just the midpoint theorem, only two concepts. So if you're clear with it, the chapter will be easy to you. I hope it is clear. Now in my next video, I'm going to explain the quadrilateral tree, the tree of the quadrilateral, how to remember the properties, and some very magical tip of how to answer the true and false. See you in the next video. Thank you.